Today we're going to look at the real number system. So the real number system is how we categorize all of the different numbers. So first we're going to look at the natural numbers. Natural numbers starts with 1, and then it's all of your counting numbers. So 1, 2, 3, 4, and so on. So all those counting numbers. Now whole numbers is the same, but including 0. So whole numbers starts with 0, and then you have all of your nice clean counting numbers all the way through infinity. So 4, 5, 6, 7, 8, all the way through infinity. And then integers. Integers is the same as whole numbers, which is the same as natural numbers. So we're just kind of building off of each layer of each category of numbers. Integers, though, will include your negative numbers. So let me actually start from negative infinity here. So all of your negative numbers, so then we have -3, -2, -1, 0. So now we have our whole numbers. So 0, 1, 2, 3, and so on, out to infinity. So these three categories of numbers are just looking at numbers like 1.0, 2.0, -5.0, not any sort of decimal values that are not ending in 0. So natural numbers, 1.0, 2.0, 3.0, 4.0, whole numbers. Same starting with 1, but then we just have 0. And in a way to remember whole numbers, whole, 0 has a whole. That's usually what helps people remember what a natural number is compared to a whole number is, because they're pretty similar, just with the inclusion of 0 on whole numbers. And integers get to your negatives. Rational numbers can be written as a fraction. So I'll just write this as a quotient of integers, we'll say. Quotient of integers. But it's written as a fraction, so like a over b. Or another way to identify it is terminating or repeating decimals. Terminating or repeating decimals. So for example, you could have a fraction like 3 over 4. That is a fraction. We could write that number as a fraction. It's also a terminating decimal of 0.75, or like the fraction 1/3. 1/3 is a fraction. That's also a repeating decimal of 0.3 repeating. So if you could write a number as a fraction, like 15 over 17, that is a fraction. That's a rational number. Even, here's what throws people off with rational numbers. Like if you think of the number 5. That is a rational number because that's 5 over 1. Or that's 5.0. That is a terminating decimal. 5 over 1, fraction, 5.0, terminating decimal. A decimal like 5.234. That is a terminating decimal. It ends. That is a rational number. If a number is rational, then it is also an integer. If a number is an integer, it's also a whole number. If it's a number is a whole number, it's also a natural number. Everything just builds. There's a lot of cool visuals that you can put together with the real number system, where the natural numbers would be here, and then the whole numbers would be here, where you just have that inclusion of 0 with the whole numbers, where the natural numbers are 1, 2, 3, and so on. And then you have like the integers, so it's the same as the natural numbers, same as the whole numbers, but then we get into the negative numbers. So like -3, -2, and it continues on. With rational numbers, you could even make another web of that. So there's a lot of cool visuals that go along with this. Now the irrational numbers, we cannot express as a fraction. Numbers that cannot be expressed as a fraction. Best example that I can give for irrational numbers is the number pi. Pi is an irrational number because the decimal expansion of pi is 3.14, and then it just goes on, never repeating, never terminating. It's just a jumble of numbers that there is no sort of 5-number pattern that says like 2, 5, 7, 8, 2, 5, 7, 8, 2. It doesn't do that. It's just 3.14, and then the decimal just keeps on going, no sort of pattern. It doesn't terminate. It doesn't get to a point where it repeats. So that's irrational. Another good example of irrational is when you take the square root of a number that isn't a perfect square. So like the number 2. Square root of 2, there is no number times itself that gets you back to 2. Where, going back to rational numbers for a second, rational numbers, like the square root of 4, square root of 4 is rational because the square root of 4 is 2. 2 times 2 is 4. So square root of 4 is 2, therefore making that a rational number. 2 is a rational number because that's 2.1. Oh, I'm sorry, not 2.1. 2 over 1, or like 2.0. You could write it as a terminating decimal. You could write it as a fraction. Where square root of 2, we can't do that. There is no number times itself that could get you to 2. Same thing with like square root of 5, square root of 7. Those are all irrational numbers because there is no number times itself that can get you to 5 or 7. Then real numbers are rational and irrational. So everything falls into this umbrella of real numbers that we would look at in this type of number system. There is the non-real number system, but for right now, I'm just looking at the real number system, which is rational and irrational numbers put together. So all the numbers fall into the category of rational and irrational that we're looking at in these two categories. Let's do some examples. Some examples here of categorizing these numbers. So given the set, we have a couple numbers, -3, 0, 2/3, -2.3, 10, -10, 1/2, square root of 3. We want to list the numbers in each category. So we want to make sure we're identifying every single category. So let's look at the natural numbers. Natural numbers start at 1. So we don't want to include 0 or negatives, and we don't want to include numbers that are fractions that aren't like over 1. And what I mean by aren't over 1 is like natural numbers is 1 over 1, 2 over 1, 3 over 1. Those are the natural numbers because they're over 1. So -3 is not a natural number. I think I'm better off just going through and putting these into the appropriate categories as I just go along each number. So I'd rather do each number. So I'm going to start with -3. -3 is not a natural number because natural numbers start at 1. Whole numbers start at 0, and then it goes 0, 1, 2, 3. But -3 is an integer because integers include the negative numbers, so -3 is an integer. Rational numbers, if a number is an integer, if a number is a whole number, if it's a number is a natural, if it's any of those three numbers or three categories, it's going to be rational. Rational numbers can be negative, it could be positive, because I could write this as a fraction, -3 over 1, -3.0, it's a terminating decimal. It's not irrational. If it's rational, it's definitely not irrational, so it can't be both. And then it is a real number. Okay, cool. Let's look at 0. So 0, not a natural number. 0 is a whole number because whole numbers start at 0 and then it goes 1, 2, 3, 4. 0 is an integer. If it's a whole number, it's an integer. Rational number, again, if it's a integer, whole number, natural, it's definitely going to be rational. If it's rational, it's not irrational, and then it is also real. Next one, 2/3. So 2/3 is a fraction. It's not 2 over 1 or 3 over 1. It's 2/3. So it's not natural. It's not whole. It's not integer. Integers are only the negative 1, 2, 3, negative 1, -2, -3, 0, 1, 2, 3, and so on. So not these fraction values, but it is rational because we could write it as a fraction. 2/3 is a fraction, so that's rational. -2.3. So this is a terminating decimal. It's not -2.0. So it's not an integer. A lot of people will see -2.3 and think integer because they see negative. They associate integer with being negative. That's not necessarily true. Yes, integers are negative numbers, but -2.0, -3.0, those kind of numbers. So -2.3 is a terminating decimal, which doesn't put it into any of these categories other than rational. So this is going to be -2.3 and real, -2.3, terminating decimal. +10. So +10 is a natural number because natural numbers start at 1, 2, 3, 4. +10 is a whole number because if it is a natural number, it is also a whole number. If it's a whole number, it's also an integer. If it's an integer, it's also rational. If it's rational, or it could be rational or irrational to be real, but it falls into the real numbers. And then we do have a -10 here, which is similar to +10, but just making sure we understand the differences between an integer and not an integer. I'm sorry, not integer, not an integer. But making sure to understand the differences between natural and whole and integer. So -10 would not be natural. It would not be whole. It would be an integer, though. And it would be rational. And it would be real. 1/2, a fraction. So not natural, not whole, not an integer. It is rational, though. And it is real. And last one that I have here, square root of 13. So square root of 13, don't confuse this with, like, if I took the square root of 16. Square root of 16 is 4. So don't see a square root and automatically think, oh, that's going to be irrational, because we said square roots are irrational. No, if the square root doesn't have a perfect square, if we don't get an actual value. Square root of 16 is 4, where square root of 13 doesn't. We can't. There's no number times itself that gets you to 13, so therefore it's going to be irrational. And if you did this in like a calculator, if you did square root of 13 or square root of 5, square root of 7, those kind of numbers in a calculator, you would just get some sort of decimal value. It would just go for square root of 13, it would be 3 point something, and it would just go on forever and ever, never repeating, never terminating, anything like that. So that's why it's irrational. And it's also real. Don't forget about that. If a number is irrational, then it is also real.